So in the last class, I just finished talking about the different isolation levels. And as I mentioned, the most strict is the serial isolation level serializable. And that's the only isolation level where the transactions actually have to execute in serial order. And the reason is because all the reads hold on to locks. So today I want to first talk about the locks, because all these isolation levels are implemented using locks. So we have both and as you can kind of figure out, whenever it comes to writes, I mean, those writes, it doesn't matter what the isolation level is. If the isolation levels are really only for reads. When it comes to write, regardless of what isolation level you specify, you could specify isolation level uncommitted, reads uncommitted. But writes are always done after you get access to an exclusive lock. And that makes complete sense. If you didn't have exclusive lock on writes, your database would be inconsistent. And reads are typically shared locks. And that makes sense too, because if you don't have shared locks, then performance would go down. And these are all locks are always typically these locks are on a row. You don't really lock an entire table usually. So most of these locks are held at row level. So locking a tuple most of the time, not always. So I just want to show you the different, for all the 4 different isolation levels, what specific locks there are. I mean, it's kind of useful to know the locks, because once you know what kind of locks are held on the back end, it's easier to understand the output. So, so I just have to write these. So we have read uncommitted. Read committed. Repeatable read, and repeatable read is the MySQL standard, and then serializable. And then we have writes. Reads. Okay, so like I mentioned, writes, regardless of the level, writes are all exclusive locks. So X stands for exclusive. And these locks are held until the transaction completes. That's the C. So let me just. So exclusive, and the X stands for that. Exclusive locks held until transaction completes. And so either there should be a rollback, or there has to be, just one second. Or it has to be a commit. So that's for the read. I mean, for the writes. For the reads, it depends on what kind of isolation level you have. So For reads, when you have read uncommitted, there are no locks, which is why you're able to do all kinds of dirty reads. So no locks for read uncommitted. Then for read committed, it's a shared lock. So shared lock held until query completes. So this is different. So when it's a shared lock, it's held for each query. So it grabs it at the start of a query and returns it at the end of the query. So this is not per transaction. You are you're only holding on to the shared lock until the query completes. So then we have the repeatable read. And so repeatable read is a bit different from read committed in the sense that when you read first, you read it into a cache and then reads. So it reads from the committed database the first time, and then it's reading from the cache for all subsequent reads. So read from committed database the first time, read from cache. So that's the read, repeatable read. And finally, we have the serializable. So we have so for serializable, you are again holding on to a read lock, but you're holding on to the lock until the transaction completes. So it's not per query, it's by until the transaction completes. So okay, so that's all the locking that is on the back end, and it's all implemented by locks. And so the longer the lock is held, and if it's exclusive mode, the lower the performance, but greater the consistency. So does anyone have any questions on the locks, on the locking mechanism? Yeah, so for this class, I mean, I'm not going, there is, you can learn about how exactly these locks work. And a lot of these locks, especially on the distributed end, there's something called two-phase locking, but that's beyond the scope of this class. I mean, that's something that would be taught in, say, a distributed systems class. Or a cloud computing class, it might be covered. So, that was, so you go into details of how exactly these locks are held and stuff like that. But for this class, I just want you to just really kind of understand, whether it's a shared lock or it's an exclusive lock, and for how long the lock is held. So that's it on the lock. So the last thing I want to do is, remember I said in the last class that the phantom tuples in a repeatable read. So repeatable read is the default standard. And I showed one example in class yesterday, and I showed that MySQL does not show phantom tuples in that one example I showed, but SQL standard, you can see these phantom tuples. But I did want to show you a case where you can see phantom tuples in MySQL, and you could try this out, when you study transactions. So let me go over the examples. So Okay, so again, I've got to show it with a very tiny little table. When you do it, you can do the same example and you can try it out on the department table or one of the tables in the database. But for this example, I'm just going to show it with a small table. So we have a table with just two rows, with two columns, A and B. So we have okay, and we have A has 5 and 10, and B has X and Y. Okay, and then we have two transactions. Of course, in order to show any kind of transaction effect concurrency, we have to have a minimum of two transactions. So we have two transactions, T1. So we have T1. And what it does is it just updates the value of A from A to A plus 10 and then a commit. That's T1. And then we have T2, which is going to be in repeatable reads. So we have T2. Okay, so one of the things I found out with MySQL is that if your transaction has only read queries, then you cannot see phantom tuples in MySQL. In order to see phantom tuples in MySQL, you have to have at least some insert, delete, or update, some kind of update kind of transaction in there. Some kind of update query in your repeatable read one. So this is not going to be a purely read query. So transaction T2 is going to have one update or kind of query in there. So this is T2, and then T2 has the following queries. We have Q1, which is select A. So this is a read query. Q2, select A. Q3, so Q3 is going to be an update query. So Q3 is A is equal to A plus 100, where B is equal to Y. So what Q2 is going to do, or Q3, query 3 is going to do, is that it is going to set A to A plus 100, where B is equal to Y. So it's the second row. Okay, so then we go back here. We have Q4, which is select A. And then you have Q5, which is a commit. Okay, and then I'm going to have transaction T3. This is just to show and this is, again, could be repeatable read. It could be anything. It doesn't matter. It's a select A, just as one query called select A. It's just going to print the value of A. So this transaction out here is going to be run by user 1. And then T2 and T3 are going to be run by user 2. So we have, so user 2 is first going to run T2, and then he's going to run. So this is user 2 will run T2 first, and then he's going to run T3. So in that order, and then T1. So we have T1 is user 1. So in T1 and can be concurrent with anything that the user 2 is doing. Okay, so let me just show you. So let's do a timeline. Okay, so I'm showing I just want to show you the table out there. So let's suppose that T2 starts up. So we have Q1 coming up. So we have T2 is starting up with select A. And I'm going to show on top, so I need to kind of build this up. So let this be user 2's viewpoint. What user 2 is seeing. Okay, so that's on the upper side of that line. And below is the reality that I'm going to show. So out down here, you can see the reality, what the database actually looks like. So when I say reality, it means what's stored, or you could say reality is what's really stored in the storage device. I think that's a better one than saying what the database looks like. Reality is stored. Okay. So T2 is starting up at Q1. So this is what T2 sees when for A. So U2's user 2's viewpoint. So he's going to see, I'm going to show A, okay? So initially A is 5, nothing has changed on A. So that's what he's going to see 5 and 10. Okay. So that means as users view of A. Okay. So now let's suppose that user 1 is starting up and he does transaction T1. So he's doing T1 out here. So we have T1. So which is A is equal to A plus 10. So once this is executed, you're going to have so this is going to be 15 and this is going to be 20 and this is A. So this is what it's looking like after T1 is executed. Okay, so now let T2 come in and do Q2. So he's doing Q2 and when he does Q2, this is what he sees. He still sees 5 and 10 and A. Okay, so this is what he does. And now let's do Q3. Now he's updating the database. So he's doing Q3. So we're going to have Q3. So I'm going to show in reality, this is what's there in storage at this time. So 15. And so this is A plus 100. So in reality, it's 120 because it had already been updated to 20. So now it's 120. Okay, so now let's go back to when he does Q4. So when he does Q4, this is what he's going to see. And this is where I said you'll see phantom tuples. He's going to see 5 on top. So that is not changing, but he's going to see the change 120 out here. So that he's going to see. So what he had updated out here, select A is equal A, but B is equal to 5. He's going to see that when he does Q4, but he sees the first row unchanged with 5. So that's where I said this, it sees phantom tuples, and then he does Q5. So that's just a commit. So now he's going to do T3. So let's look at T3. So he does T3. And when he does T3, this is what he sees. So this is after T2 is committed. So now this is, so now he'll see the exact database. So he says 15 and 120. So this is the only example. I know it's a bit it looks confusing because it is, but I could not find, I mean, when they said it's repeatable read and phantom tuples, I couldn't find phantom tuples when the query T2 only had read select statements. It's only when I added an update in there that was I able to see phantom tuples. So do you understand this example? Are there any questions on this? And so I do want to say that, MySQL will only show the phantom behavior in the rows that you updated. I could never find phantom behavior in other rows. In the row. Other rows remain unchanged. Okay, so that's it. That's all I want to cover for this class. Does anyone have any questions? Okay, so I mean, I would have liked to cover things like NoSQL and all, but I never really get time. And plus, I also think that covering NoSQL in one lecture or two lectures, you don't really get any of what it means. I would say you might as well just take Professor Diaz's class. She does, because NoSQL, I mean, you have to do a whole lot of programming on top because there's no structured query language for that. So she kind of covers that when she does information processing. But I mean, at this point, you understand enough that if you even read up about some of that stuff, you should be able to understand it. But I don't have time really to cover all of that in class. Most of the time, I run out of time anyway. So, so that's it. And if there are no questions, I'll just talk about the exam. So just move it back up if. Okay, so the exam, like I mentioned, it's on Tuesday next week from 1 to 3, but I'm going to start the exam. I think the exam before this gets over at 12:30. So I'll open this exam by 12:45 and I'll keep it open till about 3:30 or so. And I'll give you 2.5 hours. I definitely think that online exams take, especially since all of you are sitting at home, it's not the same as sitting in a classroom and taking the exam. In a classroom, it's quiet and everyone's just focused on doing it. And you're also doing it on I think that doing it on a sheet of paper is sometimes faster, at least for me it is. So I'm going to give half an hour more. So because of that, I'll start the exam 15 minutes early, because I know that there's always a half an hour gap. I mean, the previous exam finishes off at 12:30 and the next exam starts up at 3:30. So I'm going to start the exam at 12:45 and you can have up till 3:30 to finish. So it's about, you'll have 2.5 hours. Most of you will not need it, but if you need it, you have it. And again, it's going to be very much like the quizzes and all that I've given. There won't be, I'm not going to move too far away from the quizzes. So it'll be very much like the quizzes. And